All right, we are going to start our study of trigonometry. This chapter, we are going to start off with some basics of trigonometry, hopefully basics that you remember from your geometry classes. So far, probably the amount of trigonometry that you've done is what we call right triangle trigonometry. So we're going to go over that, but do know that trigonometry goes far beyond that. And right now we're just laying the groundwork, laying the basics, making sure we're all on the same page with regards to the trigonometry that you've already learned. So when we talk about trigonometry, with right triangle trigonometry, we're really talking about ratios in similar triangles. So because we're working with right triangles, we have the hypotenuse, which is the side that is across from the right angle. We have the adjacent side, which is the side of the given angle that is not the hypotenuse. And then we have the opposite side, which is the side of the triangle that is across from the given angle. It's not formed by, that angle is not formed by the opposite side. Okay, so here, in relation to angle A in this picture, we would say that C, lowercase c, is the hypotenuse. Lowercase b is the adjacent side, right? It's the side of the angle that is not the hypotenuse. And then lowercase a, that's the opposite side. It's the one that is across from angle A. Okay, now with trig ratios, you probably remember this kind of acronym that you probably used in geometry, SOHCAHTOA. Now you do need to know how to spell that in order for that to be useful. But this was a way for us to remember what the ratio of sine was, what the ratio of cosine was, and what the ratio of tangent was. Now, notice here that I wrote that there are 6 possible trig ratios, but SOHCAHTOA only accounts for 3 of them. So the other 3 that we're going to go over today, those are going to be new to you, but really all they are just the reciprocals of sine, cosine, and tangent. Okay, so say you have this triangle below. Sine of theta is equal to the opposite over the hypotenuse. Cosine of theta is equal to the adjacent over the hypotenuse. And tangent is equal to the opposite over adjacent. So that comes directly from SOHCAHTOA. If you remember how to use that, it's just telling you the ratio of which 2 sides you're using. So opposite and hypotenuse, adjacent hypotenuse, and opposite and adjacent. Now, the 3 that are what we call the reciprocals of sine, cosine, and tangent are just really you're using the same sides, but just flipping them, right? That's the reciprocal. So the first one is what we call cosecant, and that's the reciprocal of sine. So that's hypotenuse over opposite. The reciprocal of cosine is secant. That's the hypotenuse over the adjacent. And then the reciprocal of tangent is cotangent. That's the adjacent over the opposite. All right, so those are the 3 that are probably new that you haven't seen before. All you need to know is which one it pairs with. So sine with cosecant, cosine with secant, and tangent with cotangent. All right, so in example 1, it says evaluate the 6 trig ratios of the angle shown. So you're given this triangle here. I would say go ahead and label the sides to help you. So the opposite side is 5. The hypotenuse is 13. So sine of theta is equal to 5 over 13. Put that into your calculator. That comes out to be about 0.3846. Generally, if you are going to be writing things in decimal form, you don't have to, but if you do keep at least 4 decimal places. It'll help when we're doing calculations with the trig ratios. Okay, cosine of theta is adjacent over hypotenuse, so that's 12 over 13, which comes out to be about 0.9231. And tangent of theta is equal to the opposite over the adjacent, so that's 5 over 12, which comes out to be about 0.4167. Now it's said to evaluate all 6 trig ratios, so we're going to have to do cosecant, secant, and cotangent. So cosecant, that's 13 over 5, which is about 2.6. Secant of theta is going to be 13 over 12. That comes out to be about 1.0833. And cotangent of theta is going to equal 12 over 5, which is equal to 2.4. Okay, now notice for all of these, we're not trying to solve for theta. We just want to know what the trig ratio of that angle is. Now you can obviously find what the measure of that angle is, but it's not asking you to. You're just finding what is the trig ratio of the angle. So sine of theta is equal to what? Cosine of theta is equal to what? You're never asked what is theta equal to, at least not yet. All right, example 2. Evaluate the trig ratios of 62 degrees by using the triangle below. So again, I would suggest go ahead and label the 3 as the opposite side, the 1.6 as the adjacent side, and the 3.4 as the hypotenuse. All right, so now let's go ahead and plug those in. So we have sine of 62 is equal to 3 over 3.4. So that's about 0.8824. Cosine is equal to 1.6 over 3.4, which is about 0.4706. Tangent of 62 is going to equal 3 over 1.6, which is about 1.8750. All right, do the same with the reciprocals. So we have cosecant of 62 is 3.4 over 3. That comes out to be 1.1333. Secant of 62 is equal to 3.4 over 1.6, which is 2.1250. And then cotangent of 62 is equal to 1.6 over 3, which is 0.5333. So a couple of things when it comes to evaluating trig ratios using a calculator. First, for what we're doing right now, we want to make sure that the calculator is in degree mode and not radian mode. So on the graphing calculator, there's a button that says mode, and you can choose between DEG, which stands for degree, or RAD, which stands for radian. Now, you haven't learned what radians are, but radians are just another unit of measurement to measure angles instead of using degrees. But for right now, since everything we're working with right now is in degrees, we want to make sure we're in degree mode so that if we're putting in sine of 52 degrees, that is in fact 52 degrees and not 52 radians. Okay, another thing to note is that on the calculator, you see sine with like a -1 that looks like it's an exponent. Make sure you know that those do not mean reciprocal functions. Okay, these are actually inverse functions, and they help you find the measure of an angle. So in terms of reciprocal functions, you'll notice, well, we don't have cosecant, secant, or cotangent buttons on the calculator. Well, because they are reciprocals, all you have to do is find, let's say you're finding cosecant, you would find what sine of that angle is, and then whatever that is equal to, you just flip that, so you have 1 divided by sine of the angle, and that will give you cosecant of that angle. Okay, so example 3, evaluate the 6 trig ratios of 20 degrees using a calculator. So this time, instead of having the sides and trying to write out the ratios and coming up with the ratio of that angle that way, we're just simply going to use a calculator and find sine of 20. Now, if it's in degree mode, it should come out to be about 0.3420. If not, double check and make sure you've actually highlighted and hit enter for your calculator to be in degree mode. Okay, the rest of these should be just plugging into the calculator. It's just to make sure that we know how to use this on our calculator. So cosine of 20 is 0.9397, and tangent of 20 is 0.3640. Now again, you're being asked to find all 6 trig ratios. So now we're going to have to find the reciprocals. Again, remember, using sine -1 is not going to help us find the reciprocals of sine, cosine, and tangent. So what we're going to have to do is we're going to just find the reciprocal of 0.3420. Well, that's 1 over 0.3420, which is equal to about 2.9238. And then you just do the same thing with cosine and tangent. So for secant of 20, that's 1 over cosine 20, so that's 1 over 0.9397, which comes out to 1.0642. And then do the same thing for cotangent, so that's 1 over tangent of 20, so 1 over 0.3640, which comes out to be about 2.7475. All right, the next thing we're going to talk about are special right triangles. So if you recall from geometry, there were 2 in particular triangles that we call special right triangles. And that would be these 2 here, the 30-60-90 triangle and the 45-45-90 triangle. And we call them special right triangles particularly because we do end up using 30 degrees, 60 degrees, 45 degrees quite a bit when we get further along in trigonometry. Also because we actually can pretty easily remember what those ratios of the sides are. So in the 30-60-90 triangle, the shorter leg is the 1 and the longer leg is the √3. So in any special right triangle that's a 30-60-90 triangle, we always know that the hypotenuse is always twice the length of the shorter leg. Now here, obviously I've used 1 and the hypotenuse is 2. But if the shorter leg were 3, then I can say right away the hypotenuse is going to be a length of 6. Same with the longer leg in relation to the shorter leg. The longer leg is always √3 times the shorter leg. So again, if the shorter leg is 3, that must mean the longer leg is 3√3. And when we look at the 45-45-90 triangle, because it's a 45-45-90 triangle, that means it's an isosceles right triangle, which means that if it's isosceles, that means that the 2 legs have to be the same. So if you know the measure of one leg, you know the measure of the other leg. And then the hypotenuse is always √2 times the measure of the leg. So here, we're using 1 to simplify our calculation here. But say that the length of the leg was 3. Then you know the other leg is also 3, and you know the hypotenuse is 3√2. Okay, now you'll notice that there is a chart that we're going to fill out, and we're going to go ahead and use our special right triangles to fill them out for us. So we know sine, cosine, and tangent are opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. So we're going to go ahead and apply that here. So sine of 30 degrees, that's going to equal what? Opposite, that's 1, over the hypotenuse, that's 2, so 1/2. For cosine, that's the adjacent over the hypotenuse, that's √3 over 2. And tangent is opposite over adjacent, so the opposite side is 1, and the adjacent side is √3. So that's 1 over √3, or if we were to rationalize the denominator, that would be √3 over 3. All right, let's move on to the 45-degree column. So now we're looking at the 45-45-90 triangle, and we'll do the same thing as we did with the 30 degrees. So here, it doesn't matter which 45-degree angle you're looking at. Either way, you'll end up with the same ratios. So sine is opposite over the hypotenuse, so that's 1 over √2. Or, if you were to rationalize the denominator, that would be √2 over 2. Cosine, also 1 over √2, which rationalized becomes √2 over 2. And tangent is opposite over adjacent, so that's 1 over 1, which is 1. All right, moving on to the 60-degree column. So now we're looking at the 30-60-90 triangle as we did before, but now we're looking at everything in terms of the 60-degree angle rather than the 30-degree angle. So opposite the 60-degree angle is root 3. The hypotenuse is still 2, so root 3 over 2. Cosine of 60, so now the adjacent side is 1. Hypotenuse is still 2, so 1/2. And for tangent, that's going to be opposite over adjacent, so root 3 over 1, or just root 3. Okay, so now for the bottom half of the chart, well, how do we figure that out? The bottom half of the chart is just the reciprocals, right? So for, look at the 30-degree column, you only need to write down what's in the red boxes. I'm just writing out the other parts here so you can see how we're getting it, right? So if sine of 30 is 1/2, then cosecant of 30 is the reciprocal of that, so 2 over 1, which is 2. Secant of 30 is going to be the reciprocal of root 3 over 2, so if you flip that, rationalize the denominator, we get 2 root 3 over 3. For cotangent, the reciprocal of tangent, so 1 over root 3 flipped over is root 3 over 1, which is root 3. And you can do the same thing for the rest. So cosecant of 45 is root 2 over 1, which is root 2. Secant of 45 is root 2 over 1, which is root 2. Cotangent of 45 is 1 over 1 still, so it's still 1. And then moving over to the 60-degree column, cosecant of 60 is 2 over root 3. Rationalize that, becomes 2 root 3 over 3. Secant of 60, 2 over 1, which is 2. And cotangent of 60 is 1 over root 3. Rationalize that denominator, we get root 3 over 3. Now this is a chart that you will have to memorize, and in particular, the first 3 rows for sine, cosine, and tangent, that should be really drilled into your head. The rest, cosecant, secant, and cotangent, you can pretty easily figure out once you have that. One way to help you memorize at least the first two rows. So when you look at the sine row as you go across, notice that all those fractions are over 2, and as you go across, it is 1, root 2, root 3. So if you want to think of it as 1, 2, 3, that might be helpful. Then notice in cosine, it goes the other way. So they're all over 2 still, but it goes 3, 2, 1, right? Root 3, root 2, and 1. For tangent, you can think of it as I just take the numerator of sine and the numerator of cosine and divide them. So tangent is 1 divided by root 3. Rationalize it, it's root 3 over 3. For tangent of 45, you take the numerator, so 1 divided by 1, which is 1. And then for tangent of 60, again, take the numerators for sine and cosine, root 3 divided by 1, which is root 3. Okay, so that's maybe a way to find a pattern to help you memorize that, but definitely the first 3 rows you should have really solid. It'll be very helpful to just know those. You can always derive them, but it just takes time. And when you get to calculus, it will be a time saver if you have these already memorized rather than wasting time trying to derive what each of those ratios are.